All right, now I'm going to go over how to use the JPower module in Jamovi. This is a handy dandy tool that Jamovi provides that allows you to estimate the power of a study pretty quickly and easily. Again, remember, as always, power is the probability that if an effect of a certain size is really there, that your study, given its sample size, other characteristics, will be able to detect that effect, so return significant results a reasonable percent of the time. And ideally, we want power to be 80%, right? We want to be confident that if an effect of a certain size is really there, then our study, we can expect that it would return significant results 80% of the time with the characteristics that it has. In lecture and in the textbook, we've been using the power tables that the textbook provides, right? But here we are going to just do it in Jamovi. Okay. So we are going to first install the module JPower. And remember in order to install modules, you need to go over here to the modules and then to look in the Jamovi library for JPower. So find it wherever it is, install it, and then like me, you will see JPower installed here. So let's get these side by side. So this, so just remember, this is what we were using to kind of approximately find the power. Remember, I said these tables aren't extremely accurate; they're an approximation. Jamovi is going to give us a more precise estimate. So what do we do? Once you have JPower, you can click on JPower, and because we're doing a one sample t-test, you're going to click on one sample t-test. The first window here, right? So what we're doing first is I'm going to show you how to estimate the power of a study that's already been conducted. That's what we were trying to estimate using those little tables in the example from lecture. How do we do that in Jamovi? Well, here's how. The first window here, it says calculate. You want to change that to power because we're calculating power. The next window we're going to fill in is the minimally interesting effect size. And this is where you enter the effect size that we found in our output. So remember, we talked about where to find this. This is your effect size, Cohen's d. Which is 1.31. So that's what we're going to enter here. And then you enter the appropriate values for n, alpha, and tails. So our n in this case was 5, right? Alpha was 0.05, so we can leave that at the default, and tails, it was 2-tailed. Okay, and the reason why we're entering this information is because remember how what I went over in lecture was about how there's various factors that impact how much power a study has, and the ones that we talk about most frequently are effect size, n, the significance level, and whether you have a 1 or 2-tailed test. So that's all information that we need to feed into Jamovi. Once we have that, then it will give us our output, which is essentially all you need to look for to find the power is the very first cell in this table here. That power, that's 0.6 or 60%. So this study had 60% power to detect an effect size of a Cohen's d of 1.31 or greater. In other words, the true effect size in the population was at least a d of 1.31. 60% of the time, the mean of a study with a sample of 5 would be extreme enough to allow us to reject the null. So that's how we estimate power using Jamovi. Remember that one of the other things we did in lecture was we talked about how if a study doesn't have adequate power, how can we know the n that it would need in order to have adequate power? Okay, and we can also do that with JPower by changing what we're calculating. Okay, so we're going to change calculate to n. keep all of the information the same, except now that now you actually want to change your minimal desired power to 0.9 is 2. Hi, let's go 8. Right, so we've changed the minimum desired power to 0.8, although I mean you could make that 0.9 depending on how stringent you want it to be. And here is our output. So again, this is what we have here, which is the same as what I'm going to show you here. And so what you're looking for here is an N of 7. And so again, just taking into account the specific characteristics of your study, to have 80% power to detect an effect of at least 1.31, a study would need to include 7 participants. Another cool thing that you can do with J-power is you can estimate the necessary effect size that you would need for adequate power given a certain N. So if you're in a situation where you have a limited number of participants and you want to know what your effect size would need to be in order to have adequate power given your N, you can change calculate to effect size, right? And say you want 80% power and your N is 5. Then you simply look at this part of the table. Oh, sorry, we're in the wrong place here. Okay, we're calculating effect size. Here we are. Okay. So for a study with an N of 5, and if you want to have 80% power with a two-tailed test with a significance level of 0.05, you need a larger effect size, slightly larger, to have adequate power. So you need effect size of 1.68, 1.68 to have adequate power for that N. Okay, that's all for J-power for now. We'll come back to it in the later t-tests. I bet you're excited.